Hello everyone, welcome to Size of Academy. This is me Mallikarjunan. Today we are going to see the basics of Doppler radar systems and its applications. So without further delay, let's get started. So these are all our today's session outlines. So first we are going to see the basics of Doppler effect and we'll see the block diagram of Doppler radar system. Then we will move ahead with the working principles of Doppler radar systems. Then we'll see the basic equations with respect to Doppler radar systems and we'll see one example to understand it much more. So let's start with the basics of Doppler radar systems. So let's start with an example. So here we will consider ambulance which is stationary at the first case, and let's say in the second case the ambulance is moving towards, like the velocity of the ambulance is positive, which means it's moving towards the observer or it's moving away from the observer. So we'll take observers at same distance t in both of the cases. So in this case, in the first case where the ambulance is stationary, let's say suppose the siren is on for that ambulance. In that case, the sound wave is going to reach normally to the observer, whereas there won't be any deviation in the received sound. But in the other case, when the siren is on, if the vehicle is moving towards the observer, then the frequency of the signal is going to be increased. Similarly, if the vehicle is moving away from the observer, then the frequency is going to be decreased. So we will hear the deviation in the received horn sound or the siren sound. I hope you understand the concept now. Now we'll move ahead with the block diagram of Doppler radar systems, how this concept is applied to Doppler radar systems. So now we'll start with the block diagram of the Doppler radar systems. So this is the very basic block diagram of Doppler radar system, where in the transmitter section we have our continuous wave transmitter, which is responsible for generating the microwaves, and those waves are going to be transmitted to duplexer using a connector. Then the duplexer contains an antenna to transmit and receive the microwave signals. Whenever an object crosses or enters the atmosphere, the generated or the transmitted waves are going to get reflected. So those waves are going to be captured by the antenna, and that is given to the receiver section where we have a mixture. Then the signal is going to get amplified. After amplifier, we'll give it to the indicator to identify various informations about the target like position, angle or range. So this is the very basic block diagram of Doppler radar systems. I hope you understand it. So let's move ahead with the working principles of Doppler radar system. So to explain the working principles, so I'll take two cases here. So first case where the target is moving away from the radar system, and the second case is when the target is moving towards the radar system. So in the first case, where suppose if you are generating a frequency with f0 and if the target is moving away, so in that case the reflected waves frequency is going to be reduced by Doppler radar frequency. The target moving away from the radar system is going to consume some energy, which is responsible for the reduction in the frequency of the received signal. So this is with respect to the first case. When we come to the second case, when the target is moving towards the Doppler radar system, in that case we can able to see the received signal frequency is increased. So let's say suppose we have a transmitted frequency f0, then the received frequency is going to be f0 plus fd, Doppler frequency. So this is the basic working principles of Doppler radar systems. So now we will see some equations with respect to these two cases. So let's go ahead with the equations part. So in this case, as we already discussed, whenever we are transmitting a frequency, we are transmitting a microwave with frequency f0, and if the target is moving away from the Doppler radar system, then the received or the reflected waves or frequency is going to be reduced by the Doppler frequency, which means the frequency of the received signal is going to be f0 minus fd. Here fd is the Doppler frequency. So how to identify the Doppler frequency? That I will explain. So now When we come to the second case, where we are generating a microwaves with frequency f0 and the target is incoming, in that case the frequency is going to get added with the Doppler frequency. So this is the basic radar equations. Now we'll see some examples to identify the Doppler frequency, how to get it from the given info. So now we'll move on to the example section. So let's say we have given with a continuous wave transmitter with frequency 5 GHz. Now we need to calculate the Doppler frequency seen by the stationary radar when the target's velocity is 100 km per hour. So in this case, the given parameters are the frequency, which is the transmitter frequency, which is 5 GHz, and the velocity of the target or object is 100 km per hour. So in this case, our solution would be, first we need to identify the lambda, which means the wavelength of the given frequency. So now lambda is going to be c by f. C is the speed of the light and f is the frequency given by the transmitter. So now in this case, the lambda, which means the wavelength, is 0.06 meter. Just we will put it in the calculator and we can calculate it. So post that, we can identify the Doppler frequency by this formula. Fd is going to be 2 times of Vr dividing by lambda. So if we calculate the data, then in this case our answer is going to be 926 Hz. So this is how we can calculate the Doppler frequency using the given data. So thank you for watching this video, guys. Do let us know if you have any questions in the comment section, and all the class notes have been uploaded in the cloud and we have shared the links in the description. Thank you for watching this video, guys. See you in the next one.